Very good morning to all. Myself, Dr. Gopal Krishan, and I am working as Associate Professor at IIMT College of Engineering in the Department of Electronics and Communication Engineering. My today's topic for this lecture is Internet of Things. In fact, I call it as Internet of Everything. That is today's Internet of Everything. First of all, let me show this picture. This photograph shows Internet of Things. Things stands for everything that can be communicated, that can be connected, that can be equipped with sensors and communication. That's why we humans as well as other things, we call it together as things. The contents of today's presentation will be Internet of Things and its history, then how it works, the structure and components of IoT, the future potential of IoT, applications, technological challenges, criticism, controversies, future of IoT, and finally, the conclusion. IoT is a network of physical objects, as I said earlier also. It has been embedded with the communication technologies, sensors. We particularly name it as electronics, software, sensors, and network connectivity. All these facilities enables these objects to collect and exchange the data. It allows objects to be sensed, as I said earlier also, and controlled remotely across existing network infrastructures, creating opportunities for some direct integration between the physical world and computer-based systems, which results in improved efficiency, accuracy, and economic benefits. Like I discussed in the previous slide, that things in the IoT sense stands for everything that can be connected, everything that has the capability to communicate, that has the capability to send signals and receive signals, that is smart enough, right? So these devices collect useful data with the help of various existing technologies and then autonomously flow the data between other devices. Previously, the IoT initiated its origin from RFID tags, that is radio frequency identification tags, and it was seen as the prerequisite for any IoT at that point when it started earlier. If all the objects and people in daily life were equipped with identifiers, that is RFID tags, computers could manage and inventory them. So besides using RFID, the tagging of things may be achieved through such technologies as near field communication, barcodes, QR codes, and etc. This picture depicts the technological roadmap that IoT has progressed through. You can see that right from the 2000 era, initial approximately 20 years back, we found this RFID was the initiator. Then we have came up to the software agents. That means softwares are also smart enough and equipped with the other sensor technologies, which makes them unable to communicate and send and receive the data. Finally, you can see that it is the teleoperations. That means you can operate the devices at remote places without actually being physically connecting with them. So that is the essence of IoT. These are the different names for IoT: Internet of Everything, Smarter Planet, Machine to Machine, the fog, T-sensors. T-sensors stands for trillion sensors in the future, the Industrial Internet, Industry 4.0, and the Internet of Things. How it works? It works with the capabilities. So what are the capabilities? The capabilities are communication and cooperation, addressability. That means device has some address to be communicated by some data and received by some data. Identification intelligence, energy, it needs some energy to operate, integration with other devices, sensing for the inputs and outputs, actuation for the decision taking, information processing so that the captured signal can be presented as per the requirements of the data to be processed further, and user interfaces and standards. Obviously, it needs to be standardized. However, this IoT till date has not got standardized as you can compare it to the computer networks and data communication, which has a certain body, that is IEEE. This IoT lacks in this area. You can see that RFID started with the and then progressed to sensors and smart technologies, and then nowadays it has come up to nanotechnology era. That is again, this slide represents what we discussed in the previous slides. What is the structure and components then? Then we have what are the requirements? Requirements are you tag the things. That means you make them communicable. And then feeling stands for that how to sense, you need sensors for them. Then shrinking the things, obviously you need the things to be smart enough and small enough. So miniaturization, and with the help of nanotechnology, it has provoked the ability of smarter things to interact and connect within the things or smart devices. Then thinking things, that means the decision taking capability and ability embedded into the devices. These are the essence of any IoT functionality. That is, IoT device is required. That means using sensors, you gather information from the multiple sources with the help of sensors. Then gateways to communicate the data, integration of multiple IoT devices, and then networking of the data. That means various different capability devices are connected together for decision taking. Then where to store it? You need to store it at the cloud. So IoT device can be wireless sensors, software actuators, and computer devices. They are fixed to a specific object as can be seen. So it enables the transfer of data among various objects. Like Fitbit is your smart sports software device embedded onto the your body so that you can track your activity. Then what is gateway? Gateway is a device or software program that serves as a connection point between cloud and multiple IoT devices. As said earlier also, all the information moving to cloud or vice versa has to pass through IoT gateway. Network is the bridging element, obviously, to integrate various devices so as they can be communicable and they can communicate with each other. So the help is taken from the cloud platform by traditional TCP/IP network, that is a file-aware program, file-aware software. It has been existing over years, connected with a bunch of protocols. That TCP/IP is a protocol, transmission control protocol, and internet protocol. So now the same network has additional meaning of glue that bridges everything. So every device can communicate with each other with the help of those set defined protocols. And cloud is the software, that means it is used to store the information processed. The required characteristics will have that a cloud is required to have. It has the web services, it has the scalability that will scale up and down, then it has the distributed properties, then the business intelligence, analytics, cost optimization. So these are the intelligence being embedded into a cloud service. Just look at the current status and the future prospect of IoT. You can find that from the diagram, from the figure shown here, we find that in earlier 2000, approximately 20 years back, we find that every human was connected to not one complete device. And nowadays, we find that every human is connected to more than 6 devices at a time. So importance of the devices can be seen here. We call IoT as network of networks. Various networks are connected together to make a bigger and big network so that every data can be transmitted between various devices without boundaries. So what we have come up to, so earlier, the ultimate goal of the IoT, ultimate goal of the internet networking devices is to serve the humanity, to make human life simple, to address to various issues arising of various problems being faced by a human being. So right starting from the data, we have come up to the wisdom. That means we have come up to the understanding where we can take decision based on the data collected. So the hierarchy was starting with the data, you extract the information, then you gain the knowledge, then you understand the things, and then you take decision. The future says that almost when we have 50 billion machines interconnected to each other, the importance of data you can understand, and the value of the data. That's why we say that sky is not the limit, it is only the beginning of IoT. The potential of IoT, you can see that it is the picture, the photo depicts the value of industrial internet. That means connected machines and data. The use of such IoT programs and IoT technologies, it can result into the saving of the finances. It can result into economies of the various setups. Like for example, In aviation, power, healthcare, rail, and oil and gas, for a typical example has been taken. For the 15 years, if the IoT was used, in that case, it would have saved 30 billion in aviation, $30 billion in fact in aviation industry, 66 billion in power, 63 billion in healthcare, and 27 billion rail and 90 billion in oil and gas. This importance of this $1 billion you can understand with the help of this slide, where you can see that the top 10 economies of the world, you can find that if you can, like you see in the previous slide, that if all these factors are being summed up, you find that almost like $200 billion you could have saved. So $200 billion is something very big figure, big number. So like you can see that our India, you can have the economy, the total worth is $3,250 billion. So out of that, if you are able to save $200 billion, it is something 6 or 7% of the total economy. It is a big number. So it has the massive potential, obviously, and it results in improved performance, reduced cost, new revenue stream, and create innovative services also. So these all are the applications, like the first diagram it was. Everything there you can connect with the IoT, and you can save, and you can act smartly. You can save your resources. You can make your life simple. These are certain few applications to name: building and home automation, manufacturing, medical and healthcare systems, media, environment, infrastructure, energy, transportation. I mean, you name it, you name any application, and you will find it in IoT. There is a solution. So these are the applications summed up in a diagram, that from home consumer, you can go up to industrialization, connected cities and industries being connected together, to infrastructure, to health, and to transport. Just to state an example, to cite an example, 41 billion US dollars you can create or you can save by providing visibility into the availability of parking space in a metro city. That means you will not require to roam around with your vehicle looking for a parking space. It will be readily available, immediately visible with the help of IoT. So the money saved is approximate 41 billion in a typical usage of time. So that's a big number. Not even the automobiles, humans, living beings also can be taken advantage. They can be made smarter with the help of sensors. Like in the cows also, there can be a sensor which can monitor its health, which can be used to have more products, more produce, like milk and other things. Then you can have an idea of smart homes, which can detect a smoke automatically, which can control switches. Sensor shades and blinds are there, which can automatically switch on and off. Then you can adjust the climate. Then you can monitor your home from distant places without actually being present at the site. So the motive is to get some comfortable lifestyle, easy lifestyle, and to address the problems and find the solutions. So IoT makes our life simpler and more convenient. A smart home is everyone's dream home. So it helps wonderfully in connecting us with the devices and notifying us about everything at home, even when we are not at home. So this is the example that you turn on and off the lights at home, which is generally called as smart home, with including other things also, like there is a blinds are there, then the room heater is there, air conditioners are there. They can be made operative and non-operative while sitting away from your home, so that you can save energy, you can save time, and you also it helps you a lot. Then there is a concept of smart factory. Obviously, the helpful things are that you can save energy, you can communicate easily, and the urgent basis messages are floated with the help of IoT. Automation obviously is there. Then data analytics, you can collect the data, analyze the data, and decisions can be taken thereof. And obviously, it is a remote monitoring system. You're not required to be present everywhere. So smart factory is highly digitized. Obviously, the digital data is being transferred from one place to another place. So it works by employing technologies such as artificial intelligence, IoT, big data, robotics, analytics, and many more. So what are the characteristics? Is the visibility, which makes it smarter, connectivity, autonomy. So factories have for long relied on automation, but smart factory, today's concept is taking this step much further and are able to conduct without any human intervention. The extensive use of IoT sensors and devices connect machines, which give visibility into the factory processes. It is expected that robots are going to populate smart factories and will be working along men. This will help reduce manpower and will make room for better quality products. Everything IoT can do. It is now up to the imagination of we human beings that what kind of usage we want from it. Examples we have already discussed: cows, water pipes, people. That's why we call it as Internet of Things. So things stands for everything which is a human and a non-human, which has the capability to communicate, collect data, and decide. So it is a saying of Peter Hartwell, who's a senior researcher at Labs. What he says about this IoT is that with a trillion sensors embedded in the environment, all connected by computing systems, software and services, it will be possible to hear the heartbeat of the earth, impacting human interaction with the globe as profoundly as the internet has revolutionized communication. Well said. So IoT, you can say that it is the next stage of the information revolution and reference to the interconnectivity of everything from urban transport to medical devices to household appliances. So integration with the internet implies that devices will use an IP address. Obviously, the communication needs some addressing. So IP version 6 will come into picture after some time. Objects in the IoT will not only be devices with sensory capabilities, but also provide actuation capabilities. And hence the IoT will be responsible for performing actions. So decisions will be taken based on the data collected. And additional examples, like it will be in the area of heat, electricity, energy management, as well as cruise assisting, transportation systems. So these are some names which can be very important in the future with the help of IoT. Thought controlled computing is something which will assist differently abled people here. That means the thinking will be converted into some actions. What are the challenges? Challenges are scalability. Standardization is obviously required. Interoperability, because when the standardization is not there, uh, the communication from one system to another operating system or one standards to another standards will be difficult. Software complexity, obviously standardization will make it possible also. Data volumes are increasing, how to handle them, where to store them. Then the power supply requirements obviously will increase. Interaction and short range communication depends what kind of devices you are going to communicate with. Then the wireless standards for such communication being possible. Fault tolerance, what kind of faults and what severity of fault you can tolerate and what will the impacts of those tolerances. Criticism and controversies, obviously the benefits will come along with certain negative aspects also, like privacy will be vulnerable, security will be an issue, automation and control will be, there is a problem. Then political manipulation, obviously the data can be manipulated by the politicians. Then design will be an issue, environment will be impacted, what will be the issues need to be addressed. Then the influences. So examples are like the security breach. You find there is a case of May 2021 that Air India data breach highlights third-party risk. So data was leaked from the Air India passengers. Those data can be wrongly used and interpreted by certain bad people here. Police exam database, like it was leaked of 5 lakh candidates. So that data also can go into the wrong hands, and the information like Aadhaar card, their IDs, their voter IDs, their phone numbers, they can be misused. So these are the negative aspects of these IoT advancements. The future of IoT, according to the statistics, every citizen owns at least 3 IoT devices. We have seen in the initial figure that more than six will be the future, that every human is being equipped with more than six communicable devices at a time. So with these statistics, the future of IoT looks very promising. Obviously, our lives are about to turn much easier and efficient, whether we are talking about self-driving cars, ease of work through automation, or lodging in the comfort of our own homes. So finally, we can conclude that it is the concept through which the virtual world will come into picture. It has the potential to increase the availability of information available in the market. So greater number of technology will be required to support the same, and collaboration with various standard groups. Obviously, the things are required to be standardized. So these will be the requirements. We can say that it is only the tip of an iceberg. Many more technologies, many more areas, and many more applications are will be coming up in the near future with the help of IoT. Thank you.